directly first, and then if they can be done in Desmos, then I'll show those. So 1, 3, and 4 will be those three. For number 1, write the equation that goes to the given point and slope. We're going to be using our y minus y1 equals m times x minus x1. Our point slope formula, because we have a point and a slope. So this would be our x1, y1, so y minus 8 equals our slope 2/3 times x, you can put plus 18, or minus 18 and then change it to a plus. And then we can start to solve. So this would be 12, and then add 8 to both sides. So y equals 2/3x plus 20. Have any questions about that one? Number 3 is not solving for the y-intercept, it's solving for y, solving for the equation. So we needed to get rid of everything else, add 2x to the other side. So that we get y equals 2x plus 5. Now if it says solve for the y-intercept or find the y-intercept, then you would put a 0 in and solve for that. Or you could solve it like this and determine that the y-intercept is 5. And then number 4. To solve this equation, we have a fraction that equals another fraction. What's our first step? Cross multiply. So 6 to x plus 1, 18 to x minus 5. Or you could jump right into multiplying the 6 to everything and the 18 to everything. I think that's 10. And then move one variable term to the other side and one constant to the other side. So I'll move 6x and move 90. 96 equals 12. We divide both sides by 12. What is x? 8. Okay, so I'm going to show those three in Desmos. So just for the future, as you're practicing, for number 1, if you saw something like this, you would type in your y equals mx plus b. Add in all your sliders. We know the slope is 2/3. We don't know what b is yet. We can put in the ordered pair, negative 18, 8. And have to zoom out a little bit. If I just hit play on this, it's not going to ever touch it because this only goes up to 10. So I would have to change this to, if I was guessing, not solving, I could put in 10. Okay, I know that doesn't go through. So it has to be something higher than 10. So let's say I guess 15. Close, but not quite. I can keep guessing. 18, close, but not quite. 20, it goes directly through. So then I would put those two numbers in the equation, y equals 2/3 x plus 20, and your work would be did in Desmos. Questions on that one? Number 3. If I were to just put this in as is, So negative 2x plus y equals 5. Because I'm solving for y, it's going to be an equation that's y equals mx plus b. So I could graph this, see what my y-intercept is, count what my slope is, and rewrite it like that. So here my slope would be positive 2, so y equals 2x plus 5. And if I type that in, they would overlap. And they do overlap, and that's a good way to check yourself. Number 4, you could type the entire thing in. It's going to look weird at first. And it's going to show you where that would cross your x-axis, and that would be your solution at 8. Questions on how we did any of those examples? Look at your course calendar. Let's talk about some important dates. Upcoming dates. So let's start with Delta Math. You guys have 2 due on Friday. 1 will be after we do today's lesson. 1 will be after we do our lesson on Friday. But you should have time to do it in class. That way you don't have to go home and do it. And then you'll have 1 due next Friday and 1 due the following Friday. Your quiz would be in 2 weeks. Tests would be the week after that, which means all of this will be on next quarter, quarter 3. To mean whatever your grade is right now will be your grade unless you take missing tests or retakes. So keep that in mind. The last day to do retake work is Wednesday the 24th, so in 2 weeks from today. The last day for retake, so let's say you do all your retake work, but don't get a chance to retake on the 24th, the last day to do just retakes is the 25th. But you have to have all your stuff done. Questions on any of those dates? Okay. Look at your notes. So today we're starting our new unit on systems. Still talking about linear equations and functions, and we're going to talk about what those look like and things like that. So I'm going to have you start to write this stuff down. So a system of equations are 2 or more equations with the same variables. The solution to a system, graphically, is the point xy, where the 2 lines intersect. The solution to a system, algebraically, is the point xy that makes both equations true. There are 3 types of solutions when dealing with systems. If you have intersecting lines, they make one solution where they cross. Parallel lines don't ever cross, so think back to when we were talking about parallel lines. They have the same slope, they don't cross, they never intersect, so that would be no solution. And then if you get the same line, it has the same equation, so it overlaps or touches, crosses everywhere, it's infinitely many solutions. And then to solve the systems by graphing, we do the following 3 things. Rewrite the equations in slope-intercept form, if they're not already. Graph the lines, and after we graph them, we should be able to see what type of solutions they are, or which ones they are. When you finish writing all of that, go ahead and put your pencil down so I know that you're finished. I'm going to do mine in 2 separate colors. If you'd also like to do yours in different colors, you're welcome to do so. You don't have to go. So for this first one, we would graph this by starting where? it again.
I just did it. For this circle.
-8. So on the y-axis, plot a point at -8. These graphs are 10 by 10 if you want to skip instead of counting. And the slope for that equation is what? For the first one? 1. So that means we're going to go up 1 to the right 1 as many times as possible. Fill up your graph. And down 1, left 1 as many times as possible. Again, fill up your graph. Make a line, connect the dots, connect all of your dots through all of your points. Make sure it has arrows at the end. And then let's graph the other one. That one's going to start at +1. Slope is negative. What direction should I go to get a negative slope? Down, not down and left, but separately. So down and right. Down and right would make a negative, or up and left would make a negative. So you can go up 2, left 1 as many times as possible. Or down 2, right 1 as many times as possible. As you draw all your points, you'll see where the 2 cross. Where do those 2 lines cross? -5. So you would write that as an order group. And that would be your solution. Do we have any questions on how we solve a system by graphing? Alright, let's do number 2. Start graphing though. So the first one, start at +9. Slope is +1/2, so we can go up 1 to the right 2, down 1 to the left 2, as many times as possible. Connect your dots, make a line through them. For the second one, start at +6. Slope is -1, so down 1, right 1 as many times as possible. Up 1, left 1 as many times as possible. Draw that line. Where do those 2 lines cross?
-2.
-2, +8. Once you finish that one, go ahead and go to the next page. We'll do number 3. And then after we do number 3, we'll do any that you guys want to see if you go over and look. So for number 3, these are both in standard form. We have to solve them both, so I'm going to do that simultaneously. Add 3x to the other side, and add x to the other side. So that the top equation is y equals -3x plus 8, sorry, +3x plus 8. And the bottom one is y equals x minus 2. Just by looking at these 2 equations, what type of solution are we going to have? one, none, or infinitely many? One. Because they don't have the same slope, so it can't be none. They're not identical, they're not exactly the same, so it can't be infinitely many. So one. We just have to graph them and figure out where that's going to be. So graph both lines, it doesn't matter which one you start with. For the 3x plus 8, you could go up 3 to the right one. You don't need to, but you do need to go down 3 to the left one as many times as possible. Where do those two lines cross?
-5, -7.
Are there any others on this page we want to see, do, go over, have questions about? For number 5, let's go ahead and solve this first one. Subtract x on both sides. And divide everything by 3. What is that new equation? Subtract x and divide everything by 3. What would that new equation become? -1/3x -5. Okay, so then you have your two equations, graph them both. For the y equals -7, you have to remember your Poibucks. Horizontal lines have 0 slope and are y equals, so this is a y equals, it's going to be a horizontal line at -7. I'm going to graph the solved one first. So y equals -7 on the y-axis, plot a point, and then draw your line. And those two lines are going to cross where? we have to solve one of these. The other one is already given. So when we subtract x to the other side, and divide everything by 2, we have y equals negative 1/2 x plus 2. What do you notice about these two equations?
They're the same.
They're the same, which means your solution is going to be what?
Those.
Not no solution, because that would be parallel lines, but infinitely many. Alright, so I'm going to show you how to graph this, because you're not going to graph the line twice, or you can't, but there are different options. So graph the line at least once. And then to show that there's a second line, you can do one of the following. You can choose. You can either extend another set of arrows after the first set of arrows. So you have your line, it has arrows, and then after that just draw another set of arrows after it so it looks like it has double arrows to show that it would be like 2 lines. You could do that. You could highlight over top of your line that you already have to show that there are 2 lines. You could take a different color and draw directly on top of it. Some way, shape, or form you have to show that there are 2 lines. Go on to the next page. So now we're going to determine, let's say we graph and get a solution at the end, or we solve it once I show you how to solve by substitution or elimination, or we set up a word problem and we get this solution at the end, and we want to check to see, is this the solution or not? How could I do that? How could I check to see, does this work, is this right or not? What do we think? How could we check to see, is this the solution or not? We can, just like if you had a regular equation and you got a solution at the end, you could put it back in and see does it work. And if it works, you know that's right. Same thing here. We can put this x and y into these x's and y's, and see if they work. If it works for both, it's a solution. If it doesn't work for one or both, then it's not. So let's try with the first one. 2 equals negative 1/3 times 3 plus 3. We multiply negative 1/3 and 3, we get negative 1. Does negative 1 plus 3 give us 2? Yes. So that works. Then we can test the other one. 2 equals 2 times 3 minus 4. We know 2 times 3 is 6. 6 minus 4 would give us 3. So it also works. It works for both, so I can say this is the solution. So let's say you had to solve both equations to graph it, and then you graphed something and got a solution, but just to make sure that's the actual solution, you could do this. or when we solve by substitution and elimination or your word problems, you could double check yourself using those. Let's do another one. Number 3. You do not need to solve these, get them in slope-intercept form in order to use the check method. You can put them in exactly as they are. So for the first one, you have -2 minus 4 times 4 equals 12. And then simplify, so we have -2 minus 8 equals 12. I think I did that wrong yesterday. Oh, because I put them in the wrong place. I just did it -4, 4, -2. There we go. I switched the whole thing. My bad. 4 plus 8. Would 4 plus 8 give us 12? Yes. Okay. And then for the second one, 3 times 4 minus 2 times -2. So we have 12 plus 4 equals -4. If I add these together, am I going to get -4? Because this one does not work, this could not be the solution. Which means somewhere we did something wrong and we have to go back and solve and fix it. Questions on that? I want you guys to try number 2 and 4. If you finish before I come back up here, I can check it. And then we'll come back and talk about it. So I'll give you a couple minutes to do 2 and 4. Decide if this was or was not a solution. There's not a solution. Did anyone need to see that one? What about number 4? Did you find that was or was not a solution? It was a solution. Did anyone need to see that one? Okay, go on to the very last one. I'm sorry, we're not done with this yet. Review number 5, and then we're going to go to the last page. So in this one, we're not going to do many of these because it's really the same. We have to state the system and the solution. Does not matter the order. So what would the solution of number 5 be? -2, -1, where they cross. Right. To state the system of equations, we just have to write the equation for both lines. So I'm going to color code. If I were to find the equation of what is now my blue line, what is the slope of that line? So of the blue line. Oh.
-1.
The slope.
Yeah.
So if I go down 1 to the right 1, it's not at a whole line. Okay.
2 -2.
-2 and what?
2 -.
2 -1. You're talking about the red line. What about the blue line?
I'm talking about the blue one.
The slope isn't 2. So if we go down 2, it's not quite at a whole point.
I'm saying axis to the lines.
Okay, we're looking for the slope though. -3 over 2. So if I go down 3 and to the right 2, I do end up at another point. And then the liner's up.
-4.
-4. So that would be stating that system, that equation for the system. And then for the other one, what is the slope? -1/2. so this is just doing the opposite of what we were already doing. Before we were given equations and had to graph and find the solution, and now you're given the graph and have to state the equations and find the solution. Questions on that? Now go to the very last page. I'm going to show you how you can be checking your work besides the method we just talked about, but in your calculator and in Desmos. So first, reset your calculator, 7 plus 7 is 2.
Oh man, I really appreciate it.
And then we're going to do number 1 in the calculator. So you're going to go into your y equals, and you're going to put one of the equations in y1, the other in y2. So use alpha y equals 1/7 x plus 6. And then the other one, 9/7 x minus 2. Once you have those both in, you're going to hit graph. And you should be able to see that they cross on your screen. Now, if you put in something and you couldn't see where they cross, you would have to use your zoom or your window and change your window, change your zoom. And then here you have one of two options. You can either count how far up, how far over, how far up. With the calculator tick marks, I often miscount or recount the same things. So to avoid that, go into second trace. Which of these do we think we're going to be using? Intersect. So we go into number 5. And then it's going to ask for the first curve. That's just talking about the first line. Hit enter. Then it'll ask for the second curve, which is just the second line. Hit enter again. And then it wants you to guess. You don't want to guess. You want the calculator to do the work, so hit enter one more time. And it'll tell you what that intersection point is. And you would write that. So this is a way to check yourself, not a way to avoid doing the work. So you could do all the work and then use this to check yourself only if your equations are already in slope-intercept form. If they're not, you have to solve them first. Questions on how we check ourselves in a calculator? I'm going to put number 2 in Desmos, so that you can use this while you're at home practicing or while you go to practice self-math. So if I put these both in, and you'll have time to do this here in a bit, so you don't really have to do this right now. 2x minus 3y equals -9, and 11x minus 3y equals 18. And then I can see my 2 lines and see where the 2 lines cross. And then you would write that down. And while you're practicing, if your lines / intersection point don't match up, you know you did something wrong. Questions on how we check ourselves in Desmos? For the remainder of class, you guys are going to be practicing one of two things. Either you can keep working in this packet, do as many problems as you would like, or you can work on the Delta Math on what we just learned that is due on Friday. No one should be grabbing phones. You can work together, move around. While you guys are working, I'm calling you up to do course recommendations. We're talking about course recommendations. So you guys have this time to work.